I've saved the absolute best for last. We're going to do semicircles. Only because there's a little twist with semicircles that everybody seems to want to skip. All right, same figure, x squared plus y squared, perpendicular x-axis. We're still going to integrate with respect to x, except this time we are going to use semicircles. So our formula for the area of semicircles is pi halves r squared, because we're taking half of the actual area since we're only doing half of a circle. Now where the little bit of the trick comes into this, because again we know the volume is still going to be our limits, and now we're going to use this formula. Of course it's going to be in terms of x. Our challenge is figuring out what's r. What's the radius of your semicircle? Now if you look at the picture itself, we know that the entire semicircle went from one end of the circle to the other end of the circle. Great. But that length did not represent the radius of the semicircle. That represented the diameter of the semicircle. We just need this piece that goes from here to here, which would be our radius. So whereas this one is different, only part of the curve is what we need in order to be able to figure out what goes in for r squared. With the squares and the equilateral triangles, we knew that the side lengths were controlled by the top curve minus the bottom curve, but in a semicircle, we only need half of that length that you have. So be mindful of that. So instead of using 2 square roots of 25 minus x squared, which represents the whole length, our radius is going to be that side length cut in half. And that half has nothing to do with this half right here. This is just using half of this length because only half of that length represents the radius. So our radius is really just the square root of 25 minus x squared. So knowing that piece of information, like the examples before this is no different than what we've done before. Now I'm going to plug these values in. Sorry, I'm kind of going off the screen. My pi over 2 can come right out here. It's just a constant. My radius is the square root of 25 minus x squared. You're squaring that. So think about the differences and look at the differences in your notes between this problem and the other ones. We simplify before we integrate. I love when squares and square roots cancel out. It makes things so much easier. And again, our antiderivative really doesn't look much different except for the fact that we keep dealing with something different on the outside. So I've got 25x, x cubed over 3, negative 5 to 5. And again, check my calculations. When I double check this one, I got 261.799, which makes it the smallest of the 3 different shapes. And if you look at pictures of those different shapes, it should make some sense. So think about this. I'm going to give you some practice problems tomorrow in class, and I want you to think about how this kind of has played out with these 3. So again, hopefully you've taken some notes.